Hey guys, welcome back to my channel. So today we are going to discuss another problem. Problem is longest string chain. So in this problem we are given an array of words where each word consists of lowercase English letters. Word A is a predecessor of word B if and only if we can insert exactly one letter anywhere in word A without changing the order of the other characters to make it equal to word B. Okay. For example, ABC is a predecessor of ABAC. So why guys this ABC is a predecessor? Because in this ABC word we can insert exactly this letter, right? Between this B and C, and there will be basically what we need to do. We can insert exactly one letter in word A without changing the order of the other characters. So see AB, and here just this A will be inserted, right? And here this C will be there. Okay. So while CBA is not a predecessor of VCAD, why? Because see, in this CBA, this this D is an extra character, right? So if we insert D over here, so still it will be not equal to this, right? So uh, a word chain is a sequence of words. So what is a word chain? We have some words, right? This is a sequence of words with k greater than 1. So what does this mean? Where word 1 is a predecessor of word 2. Word 2 is a predecessor of word 3. Okay, so this is a chain of predecessors. This is a predecessor of this, and this is a predecessor of this. Okay, so let me explain you what does a predecessor mean. So ABC is a predecessor of this. This is a predecessor of this. How? Because see, here this AB is there, this AB is there, this C is there, this C is there, and this is one exactly. Like see, this is exactly one extra letter, one extra letter which we can insert. See here we can insert. Here we can insert this extra letter A, and this will become equal to this. So that's why ABC is a predecessor of ABAC. That is, word A is a predecessor of word B if and only if we can insert exactly one letter anywhere in word A. One letter anywhere in word A, right? Without changing the order of the other characters. So we're not changing order of other characters, right? They are still in A, B, C order, right? For example, let's say we have something like this: A, C, B. Okay, and this is A, B, A, C only. So then extra character is what? A, right? But this A we cannot insert anywhere. So like if we insert this A here, so they are not still equal. If we insert this A over here between C and B, still these are not equal, right? These are not equal. This is ACAB, this is ABAC. So what we need to do, right? What we need to do in the problem, we are given this list of words. So we need to find out the length of the longest possible word chain. Word chain will be a list in which this word is a predecessor of this word. This word is a predecessor of this. This is a predecessor of this, right? So this word, see, this word list is given. So let me write this word list. So first of all, we have A, we have B, we have BA, then we have BCA, BDA, and B. What is this? BDCA. All right. So see now how over here we have this A. We can see this BA. This A is a predecessor of this BA. Why? Because this B letter is the extra letter, and we can add it here so that they are equal. So this A is a predecessor of this BA. So this is one. Then this BA is a predecessor of what? Either BCA or BDA. So let's take BDA. because D is the extra letter. This D we can insert here. So this BA will be equal to this BDA, like so these are BA is a predecessor of BDA. Then this BDA is a predecessor of BDCA, because in BDA and BDCA this C is extra character, right? This C we can add here. So if we add here, these become equal. So this is your output length. This is the longest word chain. So what is a word chain? Word chain is that this is word 1, this is word 2, word 3, word 4. Word 1 is a predecessor of word 2, word 2 is a predecessor of word 3, word 3 is a predecessor of word 4. And this is longest. So we have to return the length of this longest, and the length is 4. Okay. So this is what we need to do. Alright. So this is a problem. I hope you understood it. So now let's see guys how we can approach it. Okay. So try to pause the video, just pause the video and try to think what you can do. We need to find predecessors, right? So see guys, think of it in this way. Let's say we have to check whether there is a predecessor of this or not, BA. So what I'll do, I will see there are how many positions we can insert a character. I can insert a character in the beginning. I can insert a character between this here, between B and A, and I can insert a character after A. So there are 3 possibilities. And how many characters I can insert here? I can insert 26 letters. Any 26 letters I can insert. Any 26 letters I can insert here. Any 26 letter I can insert here. Alright. So for example, if here I insert D, so BDA we can find one predecessor. Like this BA is a predecessor of this BDA. Guys, see, just think of it. This is so complex approach, right? We'll have to check for every position whether where we can insert, and we have to check for every letter. A, is there a predecessor? Like ABD, is there a word ABA? Then B, is there a word BBA here? Right? So this is a very complex process. Try to think it in this way that see. Let's say this is your word 1, this is your word 2. This word 2 and word 1, let's say word 1 is predecessor of word 2, meaning this word 2 has if length L1, right? Let's say if this word 2 has length L, this word 1 will have length L minus 1, right? It will have one less character. Do you agree on this? For example, this BA and BDA. BA is a predecessor of BDA. Why? Because this D we can insert here between B and A. So this BDA has 3 length, this has 2 length. So word 2, if word 1 is a predecessor of word 2, then word 2 if has length L, word 1 will have length L minus 1. Alright. So then it means, let's say if for this word 2, let's say for this BDA, what I do, I try removing, see, here what is there, in word 1 we have to insert a letter, right? Insert one letter anywhere and check. Instead of inserting letter in this, how about we delete letter from this? It means same, right? Let's say I am deleting one by one. First I'll delete this B. I check for this DA, whether DA is in the list or not. DA is not in the list, meaning this DA is not a predecessor. So then let's say for this, from this BDA we delete D. So if we delete D, we'll get BA. We will check whether BA is there in the list. Yes, BA is there in the list. So we found a chain BA and BDA. Alright. So what we will do, right? We will start from the bigger length and we will try removing each letter one by one and check if that after removal of that particular letter, the word is there in the list or not. If you are not able to get, don't worry. Let's try run once the this approach, and you will better understand then. So the test case was A, B, BA, BC, what was it? BCA, BCA, and BDA, and then there was BDCA. Okay. So since we decided, right, since we decided that we will evaluate bigger length first, like bigger length first, so we will sort this, right, in the order of length, but in decreasing order. In decreasing order. That is the first, the length which is bigger will come first. So BDCA will come first. Then it will be BDE. Sorry, BDA. Then it will be BCA. So you can have BDA first also. BCA. Basically they are same length. BA and then B and then A. Right. So what is the approach, right? What we will do? See, now there is a thing, like let's say I have this BDCA. So what I will do, uh, I will have to, I'll delete each letter one by one, right? Let's say first I delete this B. So string will be DCA. So then I will check whether DCA is there in this list or not. So this is a wrong approach, right, to search. Here we have to search whether DCA is there or not. We are going to each again and again. So this is not an efficient way of searching. What we can do is we can have a set, right? Or what you can do, other thing is that yeah, basically we can have a set in which we will store all these, right? B, DCA, BDA, BCA, and BA, and B and A. So when I have to find whether DCA is there or not, I can just directly search in set. Alright. So this will be efficient approach. So DCA is not there. So what we will do, we'll move forward. So first I deleted this B. Now I'll delete this D. So now the string will be BCA. So we will check whether BCA is there in the list or not. So BCA is there in the set. Meaning this BCA is a predecessor of this BDCA, right? Because after deleting, like, this D can be inserted here. Got it? So what we will do, right? What we will do, we found, see, right, we found this word chain, and this is of length 2, right? So we will be maintaining this, right? We will maintain this. So how we will maintain this? For this we will use a vector. Right? I'm just representing vector like this. So in the vector, right, what I will be storing is the, like, this word BCA, or let's store it using its length only. So let's say length of the BCA is what, 3, right? So for 3 length, how much is the like this basically? So initially, see guys, for each length, right, initially value will be 1, because obviously there will be at least one length word chain, right? Because we can take any word. So initially what I can do, for each length, right, we have one length, 2 length, right? So basically these are indexes only of vector, 1, 2 index. So 3, 4. Initially value will be 1. So this 1 is the max length, right? Max length of the word chain for this, like if this word is included, this length word. So right now BCA, we saw that BCA is present. So in future it might happen that this BCA has also another predecessor, let's say BA, right? It might happen, right? So we have to store that till here, how much is the word list length we need to store. right? So BCA, when we find out that okay, after deletion of D we find BCA, and BCA is there in the list. For this BCA we will, till here what was the length of the word list, we will take from the vector. So BDCA has length what, 4. So right now word list is 1 length plus, so we will whatever the length is still here, we will add that in this one. So BCA, so for this 3 length, now word list length will be 1 plus whatever is still here. So that is BDCA has length 4, so it is 1 only. So 1 plus 1, 2. So for till 3 length, right? Basically 3 letter length. So word list, maximum word list length is 2. Okay. So now what will happen? We will go to BCA, right? We will go to BCA, and for this BCA we will turn by turn. So let me uh, clean up the space. So for this BCA we will turn by turn remove the letter. So let's say we are removing B, so we will check for CA. Is CA in the set? No. So this will not be a predecessor. Let's say we'll remove this C. So then we get what? BA. BA is there in the set. BA is there in the set, right? So this will be a predecessor. So what is the length of the word list? Word list till here. Till here. So 3 length is 2, right? 2 is the list till length of the list till here, and this is also predecessor, so it will be added 1, will add in the current length, so it will become 3. So BA here 2, this will be 3 till this BA. Then after that for this BA we will remove this B, we will get A. A is also in the set, so A, this becomes a word list length. So till here, what, till here, till this BA, what is the length of the word list? It's 3, it's 3, right? So we'll add A, because A is new entry, so we'll add 1 in it. 3 plus 1, 4. So here 4 will be stored for length 1. So this 4 is the maximum value, so 4 will be the output. So I hope you understood the approach and the dry run. It will be more clear if you dry run yourself the code once. Let's see the code. So see, first of all we are creating this vector in which we are storing unordered set. So we are basically storing strings. You can, right, you can store strings as well. So see, so for the particular in we are going to each word in the word list, and in this, right, we are storing uh, length of the string is the key, and the string is the word is the value. So basically we are creating this thing, right? So basically, like, this is the set, right? You can you instead of like writing like this, you can use a vector also. So anyway, you can use a set or a vector. So here I have used vector. Then you can use a map. So map will store the till whatever the size, like whatever the string maximum word list length is for this string, and the length of the, so basically here you can store word, and here it will be the max length till that word. So what we are doing is best we have stored as 1, because obviously there will be one length at least. We are going from 16 to 0. So why we are initialized with 16? Because the maximum word length, right, is 16. Okay. So basically, okay. So now what we will do? We will check if there is a word which with one length less than. For example, let's say we have this word A B C D, and there is in the list, word list, which is initially given to us, and we have AA. So obviously this is a 4 length, right? We will check whether there is a word in the list of 3 length. Then only there is a benefit of checking, like removing each letter and checking, right, whether there is a predecessor or not. Because predecessor will have one length less than the current word length, right? I told you that. So if there is no, like see here, there is 2 length, not 3 length. So obviously then there is no benefit of checking for this. You can continue forward. So that's why we are just checking if there is a word with one less length. Otherwise just continue. Then we are going to each letter of that word. All right. And we are calculating the substring. We are checking the previous value and we are incrementing it, right? So we are just checking whether we are able to find it in the set. If it is in the set, so what we do, previous value, we compare it with the previous value, and if it is greater, so we just update it and we find out the max. So just try to dry run this code approach. You will better understand. Time complexity, see. Basically just see time complexity here. What we are doing, right, this is constant, right? So what we are doing here is we are going to each word, every word, and we are going to each letter of the max, like whatever the max length is. So it will be m into n. And for space complexity, you can see we have taken this, let's say this is a constant only. So basically the count of the words and this, right? So let's say there are m words, so it will be m space complexity. So I hope you understood the problem and the approach somewhat. It will become more clear if you dry run yourself. Try to dry run this code on this test case. And let me know in the comments if you have any doubt. If you found the video helpful, please like it, subscribe to my channel, and I'll see you in the next video. Thank you.